Zombie apocalypse.
Okay, so this time no, double integration method, but this time, let's apply this problem with an overhang. Tingnan natin yung variations of analysis. So let's get ready to be neurorized. So this time around, a problem that was discussed before, but this time we will be having a overhang on the right side. So it is either nasa left or nasa right, it doesn't matter. The analysis would be the same, the procedure would be the same. Okay? So what would be the maximum deflection of the given prop beam in terms of millimeters? So given naman yung flexural rigidity value, yung E at saka yung I pag pinagsama. So again, ito yung mode of analysis natin. So let's try to assume na yung mga reactions. So shear A going up. Okay, reaction be going up. And then tingnan natin na, what if I assume moment at A to be clockwise? Okay, although in my past discussion, I did announce that most likely that the moment of interaction will be clockwise, counterclockwise, I mean, on the left, and most likely, if the fixed support is located on the right, the moment could be positively rotating, or a clockwise moment. So, if the loss is only gravitational. So, let's take a closer look kung talagang tatama yung ating sinabi before. So, assuming those, so we will try to put a cutting plane at the very last segment, so which is BC. Okay, just like this. And then I want you to notice that the load is touching the plane. However, it is not increasing in nature. So let us make a way just like what I have discussed in the last discussion. So yan po, parang ganyan yung mga nangyari dati. So di ba merong dinagdag na area na before wala. So ilalagay natin sa baba na ang load niya is pataas. Okay? So therefore magiging load of analysis natin para kang may load na rectangular lang sa taas initially for the analysis of deflection and the slope. Okay? But statically speaking, the net reaction or the net value will be the same. Pero may epekto kasi yan sa deflection. Kaya so we need to do this as a general rule. Lagi pong dalawang tanong dyan. No, one is touching the cutting plane, lahat ng load dapat. Pangalawa is the load should be increasingly in nature pag first degree and higher. So to continue, yung ating triangular load na pataas ang nature niya is nasa baba. So sanay tayo pag ang load nasa baba pataas at load ang nasa taas pababa. So apply natin yung natutunan natin before sa statics of rigid bodies. So as we continue, we will try to generate an equation, but we need to derive first the function of y, which is based on the figure, no, a triangle. So y as to x, kasi x yung distance natin, and equals 4 as to 7. Kasi ang reason yan, the same discussion, pag diretso natin, kumbaga, ito yun, no? So ito yung y, at ang max value na, pag diniretso ito, eh, same lang din naman dito. So therefore, if this is 4, this is also 4. Okay? So therefore, that would be 4. This is x, and the whole distance is 7. So yan yung nature ng computation niya. So that's why we will be having this, no, as an equation, shear AX. Ang RB natin matatamaan ngayon. So with the distance of x minus 6. And then moment at A, clockwise, positive, inassume ko ng positive. And rectangular load going up, positive 1/2 of y, which is 4x over 7. And the centroid of x or third. No? Don't forget that there's a distance of x for the span. Kasi ito pala yung y natin in the equation. And minus the rectangular load, 4 times x, and then the centroid x over 2. Now, upon simplification, we will be getting this. Okay, so these are the equations. No? EIY double prime upon simplification, and then after integration, and after double integration. So don't forget, there is values, no, na kailan natin i-eliminate, or there are, I mean, C1 and C2. But you will notice that there are 5 unknowns. 2 arbitrary constant and 3 reactions. So can DIM solve for this? Let's find out. Again, very important parameter for our analysis. considering the leftmost portion, again, point A will serve as a 0, 0 coordinate without deflection muna. So therefore, we know that at x is 0, y is 0. And also, the slope at the fixed support is 0. As discussed before, ulitin lang natin, at fixed support, no? At fixed support, sige, buuin na natin, support. Lagi po ang property niyan, y and y prime are both 0. While at the hinge, okay, hinge or roller, the properties is the same as discussed before. Y is only 0. The base assumption of this, if this is non-yielding. Kapag yielding po, specified po dapat yung settlement, okay, or the property is a spring whose stiffness is provided. Okay, fixed support, sorry, nawala yung letter D. Past tense po dapat. So therefore, we will find out that C2 and C1 are both 0. If you just only apply at x is 0, y is 0, so everything is 0 because 0 minus 6 is 0. Okay, 0, 0, 0, and 0. C2 is 0. At x is 0, y prime is 0. So using the EIY prime equation, again, 0 share x squared over 2. 0 minus x is 0. 0, 0, 0. Then C1 is 0. So therefore, ang natitira na lang pong ano natin dito ay ang reactions. Shear A, RB, at ang moment at A na inassume natin positive, upward, shear A, RB, and clockwise to positive naman tayo sa moment at A. So, after knowing that the arbitrary constants are now being eliminated, let's proceed with the evaluation of the reactions by getting the next property at the hinge support or maybe roller support. First things first, we analyze at x is 6. No? Ito yung property of 6, 0 by Cartesian coordinate system. So at x is 0, we know that deflection is 0. So therefore, as we use the third equation, EIY equals shear A over 6, which is x is okay. So 6 yung ilagay natin, and then 6 minus 6 is 0, so nawawala yung RB, tanggal na. MA, and of course, everything follows, so therefore, you can get this first equation. Okay, so therefore, shear A and MA is unknown. So natanggal yung RB in the moment. Ngayon, to get the next equation, notice that if we have this beam, for example, no? Notice that the beam will deflect like this. Sample is deflection. Ang gusto kong mapukusan ninyo, yung nasa overhang, pwedeng bumaba, pwedeng tumas. But one thing is common. Both of them exhibiting negative concavity. Kasi tandaan po natin, sa concept of bending, di ba it is said to be kapag parang nakangiti, yan yung positive bending or the concavity is going down, okay? Kapag ang concavity is going up, okay? Or parang naka-sad face siya, no? Yan yung negative eh. So therefore, either of the two, notice that per simulation is concerned, either bumaba or tumaas, lagi silang pa-negative. So take a closer look on this. That's why EIY double prime is the moment rotating on point B. Now, notice that at point B, kung ito yung roller support, mayroon ka ditong rotate dito. Okay? Now, misconception is, hindi po ang rotation ang reference ng bending. It is the concavity that matters na nagne-negative. Okay? So, dahil ang bending nito, sample is pag ganyan or kahit pataas, is up to you. Mapakita naman natin mamaya kung ano yung deflection of the tip of the overhang. So, regardless, so we need to get the moment equivalent to this as a couple, and then it is a rotation clockwise. So, do not be misguided na ito yung positive. That's why, ang load value kasi nito, if you will trace, that is 4 over 7. Paano po nakuha yan? So, gusto nyo, i-supply at x is 6. No? Makukuha naman natin yan. Anyway, pag sa kabila, sorry, if x is 1, no, pag papunta ka sa kaliwa, that is also 4 over 7. Or pwede naman ganito para maging mas madali. I'm talking about yung x natin na nasa kanan. Or gusto nyo, this is the case, this is 4, this is 7, andito yung kailangan yung bagong y at the distance of 1. O that is y as to 1 equals 4 as to 7. So that's 4 over 7, yung nasa nature ng load na to. Okay? So tanggalin ko yung pula. So ibig sabihin, ang load value niyan, that is 4, mali ako yata ng tinuro na point, no? Ito. Yan. Yung pula na yan. that is 4 over 7. So, by triangulation. So, getting the moment, 1/2 of 4 over 7 times a distance of 1. And ito 1 meter kasi. And then the centroid, 1/3 of 1. Papunta kasi dito dapat sa roller support or hinge support. O bakit negative yan? Eh sir, clockwise po yan. Hindi po rotation tignan, yung bending. Kaya kahit magkabilaan pa yan, sabi natin double overhang, as discussed in my past video lecture, ulitin lang natin, kahit gumanito pa ang bending yan, o pwedeng tumaas ito, okay? Regardless, both of them are exhibiting negative bending. So therefore, both sides are providing EIY double prime as negative rotation. So yan yung interpretation ng negative. So therefore, you can have your second set of equation. Nandaan nyo, hindi po zero EIY double prime sa B. Kasi it is a sign of what we call interlocking moment that we will try to discuss as we go higher to the topic. Okay? So, two equations to unknown, then we can now get the shear reaction and moment reaction at A. So, by that, using two equations to unknown, using algebra, we will be getting these two. Notice that shear A is positive, tama assumption natin pataas. However, MA is negative, meaning mali lang yung direction na analysis. So, clockwise natin in-rotate, therefore, it should be like this. Should be counterclockwise now. Okay? So, talagang itatama ka pa rin kahit mali assumption, basta you are doing the procedure right. Okay? So, ito yung mga reactions natin, shear A and MA. And of course, we cannot completely use the EIY and EIY double prime, Y prime, kapag wala tayong value na RB kasi apektado. So, performing EFY equals 0, or if it's up to you, you can take a moment at A to be equivalent to that computed value. No, 1129 over 105 rotating counterclockwise. Either way, you can have the same answer. So, RB is said to be positive. Meaning, tama assumption ko na pataas, 767 over 210. No? This is discussed already from statics of rigid bodies. So, by this, we can now use the shear A, MA, and RB to solve for the desired question. This is the maximum deflection. Okay. So, by this, kung nakikita ng papansin ninyo, na binalik ko yung pagiging negative niya para hindi ko na i-reverse yung sign. Ganun din naman eh. Kapag ni-reverse yung moment, so positive of negative is negative. Likewise, i-correct ko na siya, which is negative yun yung may input. So, I will stick to my assumption, and my answer is negative. Doon, isasalpa ko na lang isa-isa. Okay, so let's consider the tip of the overhang. The rule is, kapag nagkaroon kayo ng maximum deflection, lahat ng tip of the overhang at saka yung span, either what we call, if there is a single or double curvature, as discussed already in one of my video lecture, you have to follow and check and qualify kung may single curvature. So therefore, kung may single curvature, may isang point lang na maximum sa span. So we are talking about center support to support system, excluding the overhang. Pero pagka double curve, as discussed already in my past video lecture, you have to find if there are 2 points, maxima and minima condition for bending. So, magiging apat yung source kung dalawang overhang. But here, it can be 2, it can be 3. Pag 2, single curve. Pag 3, double curve. So, by this, at x is 7, we can simply say that y is delta d. And let's say that is the candidate for maximum deflection or delta max 1. So, supplying all the data. So, I think all of the values will activate for this. Kasi 7 minus 6 is positive. So, you have to accept this value. And then, finally, we are already aware that C1 and C2 are 0. So, that is positive 901 over 105 kilonewton cubic meter. And a positive deflection means an upward direction. So, by double integration method. So, aangat siya. Ibig sabihin, potentially, ito'y bumaba, tapos ito'y umangat. Parang ganyan. Teka, masakit sa mata. Gawin natin violet. Just like this. Ito, yan. Draw in violet. Umangat siya. So, as an amount of point C, you know, which is, oops, it's not point D, you know, point C. So, this is around point C. Okay, delta C. Yan, that's delta C, sorry. So, that's delta max 1. So, then we can get 901 over 105 kilonewton cubic meter. By conversion, it will become delta max 1 or 0.0286 millimeter that goes up as a candidate. So, di pa natin alam kung ito talaga yung maximum deflection eh. Now, we are now going to investigate yung sagot natin sa span AB. Letting go, that is delta C, not delta D. So, typo error lang ito, delta D. Okay. So, this time, let's consider the span. Pag sinabing span, support to support. So, isa rin naman yung segment AB. So, if y is delta maximum, y prime is 0, of course. X is what? So, ang segment kasi ng AB natin is from 0 to 6 eh. So, therefore, by using the equation of EAY prime, okay? So, therefore, using 6 as the boundary maximum, so RB will be 0 because 6 minus 6 is 0. So, everything will be part of the calculation except that C1 and C2 are 0, right? So, therefore, you can have these four values of the roots kasi quartic equation. Of course, immediately you can have one value of x as 0 kasi we are aware that the fixed support, no, fixed support has a value of 0 slope. So, it will appear immediately on the equation. Pag yan wala, or near to 0, there's something wrong with your calculation. Okay? So, of course, we cannot accept 16.4728 and 8.1728 because that is out of the span, out of the length of the beam itself. And we will try to check if 3.3544 is acceptable. And this is acceptable because it is in between 0 to 6. So, we will try to solve at x is 3.3544. What would be the result of delta max 2 in comparison later for delta max 1? To declare who is greater, that should be the maximum deflection, regardless of the direction. It's either upward or downward. The magnitude will be immediately compared. So, we will be getting this, negative 14.4789. So, negative means a downward deflection. Again, by using conversion properly, you will get 0.0483 millimeter that goes down. And we will try to compare now that in delta max 1. So, this will be the representative, delta max 2 for the span. And delta max 1 will be the representative for the overhang. Now, we can compare since we already identified all important and critical points of deflection. So, looking in the value, we know that delta max is more than delta max 1 because 0.0483 is higher than 0.0286. Then, we can safely conclude that the delta maximum is lying on the span AB, okay, whose value is 0.0483. So, finally, ang kanyang deflection is parang ganito nangyari. No, I will try to remove the load. So, ito yung magiging deflection property niya. Bumaba, then tumaas. Okay. Yung pagbaba, mula dito hanggang dyan is delta max of 0.0483 millimeters with a distance of as declared earlier. Okay, you have to provide that. And this one is going up of 0.0286. So this would be our deflection diagram for the given span. And I mean for the given total length of the beam. So this will completely discuss if there is an overhang for a prop beam because potentially there can be one side of overhang. We cannot opt to use double overhang because the other side is a fixed support. We cannot have an overhang on the fixed support side. So parang ganito, yan. Dinowing ko lang. So ito yung totoong nature na ng load ng reaction. So itong moment at A na to, hindi na dapat pa clockwise. It should be erased, no? At ito yung dapat na mangyari. It should be by true correction, no? That is already a counterclockwise because we obtain negative for the assumption of positive clockwise. So beam bending will be looking like this. Yan. Okay, then pag ganyan. Okay? I hope you learned something new today, and as our tradition goes, you have been neurorized and see you in our next video lecture.